Solcoal WA is a green energy company that owns 20 solar farms across Western Australia. The generation capacities in megawatts of the solar farms are displayed in the histogram below. Suppose that one of their solar farms is selected at random. Let the random variable W denote the generation capacity of the randomly selected solar farm. Complete the following table of cumulative probabilities for W. Well, first thing to note is if we add up all the heights, 4, 8, 6 and 2, we get 20. So for the first one, it would be 4 out of 20, which is 0.2. The next one is then twice as high, so it's 0.4. Should be reasonably clear now that this one's 0.3 and this one's 0. So now go to the table and we can see these are cumulative. For 5, it's 0. We can see here that there are no bars below 5. For 15, it's 0.2. For 25, remember it's everything less than 25, so 0.4 adds 0.2, which is 0.6. And then for 35, it's going to be add on the 0.3, so 0.9. And finally for 45, it's 1. So we want the probability that W is greater than or equal to 35. Just referring to my graph above or the table, we can see that that is 0.1. Assuming the solar farms are uniformly distributed within each interval, estimate the probability of W being greater than or equal to 20. So 20 is halfway across this interval, so that will be 0.2, add 0.3, add 0.1. So that one there is going to be 0.6. And then we want to estimate the expected value, EW. So we know that the expectation of W is going to be each value, which we'll take as the central value, times the probability. So the first one is going to be 10 times 0.2, and then the next one would be 20 times 0.4, and so on. So that's going to be 10 times 0.2, add 20 times 0.4, add 30 times 0.3, add 40 times 0.1, which is 2 plus 8 plus 9 plus 4, which is 23. To increase the generation capacity of its solar farms, what they do is upgrade all the solar panels with the latest technology. A new random variable Y denotes the generation capacity of a randomly selected upgraded solar farm. The random variables W and Y are related by Y is equal to AW for some constant A, which we're going to need to find. Given that W and Y have variances, so the variance of W is 81, and the variance of Y is 3, 2, 4. Determine the expected value. So variance of Y, given this relationship here, is A squared bar W. So 324 is A squared times 81. A squared is 4, so A is going to be 2. A has to be positive here. The expectation of Y is then going to be twice the expectation of W, which we know is 23. So it's 2 times 23, giving us 46.